All right, so 3 of you are going to watch this video and see that we're talking about horizontal asymptotes. So I am so excited that I get to spend the next 10 minutes for 3 people. But hey, it's my job. Why am I complaining? I'm not. Anyway, number 1, horizontal asymptotes. When we're trying to figure out what a horizontal asymptote is in a graph, there are 3 conditions, or 3 possibilities, I guess. And so one of the possibilities is if our highest exponent, which is called degree, so if our highest exponent, which in this case is 4 in the numerator, is greater than the highest exponent, which in this case is 3 in the denominator, then this has no horizontal asymptote. So if we're looking for horizontal asymptotes, we look at the highest exponent in the numerator and compare that to the highest exponent in the denominator. If the numerator's exponent is larger or greater or higher than that of the denominator, then there's no horizontal asymptote. A hard way to explain this is quickly that as you start plugging in numbers here, the larger your x values get, the faster that your numerator approaches infinity than the denominator. So that's why there's no horizontal asymptote. That'll be more clear in calculus. Number 2, comparing the exponents. So in the numerator, notice how my exponent is lower in the numerator than it is in the denominator. When your exponent is higher in the denominator than it is in the numerator, then this, we have a horizontal asymptote at x equals 0. Not x equals 0, y equals 0, because it's horizontal, sorry. Horizontal asymptote at y equals 0. So horizontal, it cuts through the y-axis at 0. And that'll happen every single time that your lowest degree, your lowest exponent, flipping A, dude. All right, edit. So confused. I had a blooper, so I had to restart. Go Tigers. Anyway, in this problem, again, we're looking at the exponent in the numerator and comparing that with the exponent in the denominator. So if our higher exponent is in the denominator every single time, no matter what, then this, we're going to have a horizontal asymptote at y equals 0. And that'll be true every single time. Horizontal, remember, goes left and right. And so what this means is that it cuts through the y-axis at 0. So every single time, if our higher exponent is in the denominator, the bottom of our fraction, compared to the higher exponent in the numerator, the top of our fraction, then it'll always be y equals 0 for a horizontal asymptote. So that is the x-axis, right? Y equals 0, x-axis. All right, finally, number 3. Let's take a look at this. So notice how our exponents are the same. So if our higher exponent is the same, then what we need to do is we need to look at the leading coefficient of the numerator and the denominator. And so what we're going to say is we have a horizontal asymptote at 7 over 14. So we would say, hey, I have a horizontal asymptote when y equals 7 over 14. Well, let's reduce that if we can. So 7 over 14 is 1/2. So really, I have a horizontal asymptote at y equals 1/2. And that'll happen every time. So there are 3 cases. 1, if the higher exponent is in the top of our fraction, then there's no horizontal asymptote. If the higher exponent's in the bottom of our fraction, then we have a horizontal asymptote on the x-axis, which is the equation y equals 0. And then if the highest exponents are the same in the top and the bottom, then we look at the leading coefficients, the numbers attached to those variables. We write that as a fraction, so in this case 7 over 14, which reduces to 1/2.